In this video, we are going to learn about exponential functions. We have two objectives. We want to be able to graph exponential functions. We'll also talk about some of their properties like their domain, their range, and their asymptotes. And we also want to be able to evaluate exponential functions, and that is something that we will primarily do in the calculator. The first thing that I will point out about exponential functions is how they are different from power functions. Power functions have a number in the exponent, while exponential functions have a variable in the exponent. So notice the difference between what we see on the left and what we see on the right. On the left, the 2 and 3 are in the exponent as power functions. On the right, the numbers are the bases and the variables are the exponents. The general form of an exponential function looks like f of x is equal to b to the x, where b is the base of that exponential function. It is a real number that is positive. And that's going to be important for us later on in this course, remembering that that base is positive and the base is also never equal to 1. Because if the base were equal to 1, then it would just be the constant function of 1. Now we're going to look at our first example where we graph an exponential function. To graph the function, we're going to complete a table and plot points. I will fill in the table with x values, and then we will go and use a calculator to fill in the table with the y value. So now I'm ready to start plotting the points that are on this graph. Notice that the y values, as x gets negative, those y values are getting very, very, very small. These y values here are getting very close to 0. Now I'm ready to come in and connect these points. Do make sure that you're adding an arrow to both ends of the graph because it continues on forever to the right and to the left. Let's talk about the domain of this function. Just looking at this equation here, there's no denominator, there's no even radical. We can also see on the graph it continues off forever to the left and the right. The domain of this exponential function and any other exponential function is all real numbers. The domain of all exponential functions is all real numbers. For the range of this function, we cannot just look at the equation and see the range. We need to look at the graph. So we're looking at what y values the function covers. It does not appear as though this function ever goes under the x-axis, and it does not. So in other words, what I'm saying is that none of these y values are ever going to be negative. None of them are ever going to be negative. Moreover, none of them are ever going to be 0. When we take a number and put it as an exponent on 3, we're never going to get 0 out. So this function never hits 0 as a y value. It just gets very close to it and goes upward towards positive infinity. In terms of asymptotes, exponential functions have horizontal asymptotes. And the horizontal asymptote is where the function is leveling out at. The number that shows up in the horizontal asymptote, which always has the form y equals, should be the same number that we see in the range, because this function is leveling out along the horizontal line of y is equal to 0, the same 0 where the graph is leveling out to start its range. Note that if the function had been shifted up or down, it would change the function's horizontal asymptote, and it would also change the function's range. So that finishes example 1, where we looked at an exponential function with a base equal to 3. Now we're going to look at example 2, where it is tempting to think that the base of this exponential function is 2, but this is 2 to the negative x, which is the same thing as writing 2 to the negative 1 raised to the x, because we know that we combine these exponents by multiplying, and negative 1 times x does give us negative x. But 2 to the negative 1 is the same thing as 1 over 2 with an exponent of positive 1 on it. And it still has that entire exponent of x on it. All this to say that this is the same thing as 1/2 to the x. So the base of this exponential function is equal to 1/2. Now, it wouldn't matter which version you put in the calculator, whether you put 1/2 to the x or whether you put 2 to the negative x, they are the same thing, but I rewrote it so that we can see what the base is when only x is in the exponent. To help us graph this, we're going to fill out a table. I'm going to choose these x values. It's not terribly important which x values you choose because, as we know, the domain of this and any other exponential function is all real numbers. But now I'm going to fill out this table so that we can get some points to plot. So now that I have all of these points plotted, I'm going to connect them. Notice that this makes the same kind of shape as the previous example, but it goes the other way. It's a decreasing function instead of an increasing function. The range of this function is still 0 to infinity. This function does not touch the x-axis. It has a horizontal asymptote of, again, y is equal to 0, because that's where this function is leveling out at, since it was not shifted up nor down. I want to talk about why these functions have two different shapes. And what I mean by two different shapes is why this function here is from left to right moves upward and is increasing, while the second graph that we looked at from left to right moves downward and is decreasing. And it all depends on the base of the exponential function. In the first example, the base was equal to 3. So the exponential function is increasing when the base is greater than 1. In the second example, the base was equal to 1/2. So an exponential function is decreasing when the base is less than 1. Keep in mind, though, that the base is never going to be negative. So when I say less than 1, I mean positive fractions that are smaller than 1. In example 3, we're going to do the same thing. We're going to complete a table to help us get some points that are on the graph of this exponential function, and then we will connect those points to draw the graph. So I've just chosen some random x values, and now I'm going to plug them into my calculator to get the y values out. Now that I have my table complete, I'm ready to go to my graph and start plotting my points. So now that I have these points plotted, I will connect them. And I'll put arrows on both ends of that function there. I want to talk very carefully about how we connect these points, because we definitely know that the domain of this exponential function and any other is all real numbers. But what about the range? Because we know that the range of this function is not all real numbers. So when we could draw this graph to connect these points, we should not let this piece here that's off to the left side, we should not let that piece increase indefinitely. So pretend that I am hitting these points, which I'm not, but we should not let that piece increase indefinitely. This does not continue to go up and up and up and up. It does level out somewhere, so we need to look at the equation and think about where this function levels out. It levels out at the horizontal line of y is equal to 1, because this function was shifted up 1. A better way to look at it perhaps would be if we put the negative 2x plus 1 in the front to see that we have a reflection over the x-axis and a shift left 1, and we also have a shift up 1, which would make the range have the number 1 in it. Notice I didn't say the range necessarily starts at 1. I said the range has the number 1 in it, and it would make the horizontal asymptote y is equal to 1. Now, why I said the range doesn't necessarily start at 1 is because we can see from the graph that the range starts at negative infinity and goes up to 1. So it's not always necessarily that the range is going to be written like one of these ranges here, where it starts at a number and goes up to infinity. because if the graph was reflected over the x-axis, the range would then start at negative infinity and go up to whatever your horizontal asymptote is. So one piece of advice I do have when you're graphing an exponential function is that you should always graph the horizontal asymptote with the exponential function, because that way you make sure that your graph is leveling out where it's supposed to be leveling out at. Here we have a quick reminder of transformations. So here we can see the parent function of this example 3 was simply y is equal to 2 to the x. There are a few transformations that are going on there. What's happening in the exponent with that x plus 1 is going to shift the graph left 1. Then we have a minus sign in front of that base of 2. That is going to reflect the graph over the x-axis. This is going back to lesson 10 on transformations. And then the final transformation we have is the one that is being added in the front, because it's technically as if they put a plus 1 on the end of the function, and that is going to shift the function up 1. And this up 1 is perhaps the most important transformation, along with the reflection of the x-axis, because the reflection of the x-axis is what changes the range to start at negative infinity, and then the up 1 is what shifts the range up to end at 1. Final objective in this lesson, which is to evaluate exponential functions. We want to start off specifically evaluating exponential functions with a base of e. E is a number, it's a constant, kind of similar to how pi is, and it's also an irrational number. It has some applications in finance, but if you take this expression here and you let x get infinitely large, that expression will approach this number, which is what E is. There is a button on your calculator for E. To do examples 4 through 7, I could put in my y equals e to the x and then go to the table and replace x with 2, negative 3, the square root of 7, and pi to get these approximations. So e to the second rounded to 4 decimal places is 7.3891. E to the negative 3 rounds to 0.0498. E to the square root of 7 rounds to 14.0490, and e to the pi rounds to 23.1407. In our last problem, we are going to be graphing an exponential function with a base of e. Note that e is about 2.78, and that is bigger than 1, so I do expect to see an increasing exponential function. I'm going to fill out this table with some x values, and then we will plug them into our equation to get our y values out. So I've just put this function into the y equals of my calculator, and now I'll go to my table and write down what y values I see. And now we're ready to start plotting our points. So negative 3 is very close to the x-axis. Negative 2 is a little bit higher up. Negative 1 is up at 1. 0 is almost at 3, but not quite. 1 is a little bit past 7. 2 is all the way up at 20, so that's way up there. And 3 is even higher up. So now I'm just going to connect these points, and I'm going to make sure to level out along the x-axis because this function was not shifted up nor down. And if there's no shift up and there is no shift down in an exponential function, then that means that the horizontal asymptote is the horizontal line along the x-axis of y is equal to 0. In our case, the range is 0 to infinity, and our domain is all real numbers.